Can domain of reciprocal function be all real numbers? That is a big question. Many times students think that reciprocal function means that there has to be a vertical asymptote or some kind of restriction. Since normally we consider function, let's say f of x equals to a linear function, let's say 2x plus 1, and then the reciprocal function will be, let me call that as r of x, will be 1 over f of x, which can be written as 1 over 2x plus 1. Now in this particular case, denominator is going to be 0 for x equals to minus half. And therefore, there's a restriction. And then we say, well, the domain of this function is all real numbers, but x is not equal to minus half. And that's with most of the functions which we are considering, right? We could consider a function like gx equals to x times x minus 1. In that case, the reciprocal function could be written as p of x equals to 1 over x times x minus 1. And in this case, x is not equal to 0 or 1. So most of the examples which we consider do have a restriction. But how about the function h of x equals to, let us say, x squared plus 1? Now this function is always positive. It will not have any x-intercepts if we plot it, right? Now reciprocal of this function, that means 1 over h of x will be equals to 1 over x squared plus 1. Now denominator is always positive. It can never be 0. And therefore, we have no restriction. Correct? So in such functions, we find that domain d of x is equals to, or rather we can say, x belongs to real numbers is the domain of such a function. Right? So therefore, we have many examples where domain of a reciprocal function is indeed all real numbers. So it's a very important concept to understand as we move forward. I hope that helps. We'll also look into domain of other functions which could have always all real numbers as their domain, right? So we'll consider them in the following videos. Thank you and all the best.